Hello everyone. First of all, I would like to thank you for attending this presentation. I am Hiba Youssef, a PhD student at Streamroot and Telecom Paris. Today I'm going to present you our paper titled Enabling Adaptive Bitrate Algorithms in Hybrid CDN and Peer-to-Peer Networks. In this presentation, I will introduce you the main motivation behind our work. Then I will explain the challenges we faced and what we proposed as a solution and the results we got. Then I will summarize the paper with the future work. As we know, the video traffic is increasing massively, and according to Cisco, it will account for 82% of the global internet traffic by 2022. This puts an increasing pressure on delivering a good quality of experience to the end users. And in this context, many solutions have been proposed. However, as you know, the ABR adaptive bitrate solution was shown to be the key feature for the video delivery over the internet. In ABR, the video content is encoded in two different qualities and segmented into different segments, then stored on a server. And the choice of which segment at which quality to download is left to the client side, who usually runs an ABR algorithm to sequentially request these video segments from the server over delivery networks, most likely content delivery networks CDN, or in another scenario peer-to-peer networks where the users are exchanging video segments between themselves. The current implementation of the client-side peer-to-peer solution is in most of the web browsers involves integrating the video player module on top of the network module. In the network module, there exists an orchestrator-like module which forwards the request between CDN and peer-to-peer. In the case of the traditional content delivery network CDN, the orchestrator forwards the traffic to the CDN only. And in the case of the peer-to-peer, this module enables the prefetching mode from peer-to-peer. In the prefetching mode, the peer-to-peer downloader tries to fetch some video segments from the other users ahead of the video player request and store them in a local peer-to-peer cache. And thus, when the video player requests the segments that is locally cached from the peer-to-peer cache, the orchestrator will just forward this segment instantly, and so on, until the requested segment is missed in the peer-to-peer cache, and the orchestrator will forward this request to the CDN. Before talking about the challenges of merging ABR and peer-to-peer, let's have a look on the main classes of the ABR algorithms we have in literature. As we mentioned before, the video player runs an ABR algorithm which usually belongs to one of three main classes. Throughput-based class, if it relies on TCP throughput measurements for the bitrate decision, like conventional, Panda, and Festive. Also, we have buffer-based class if it relies on the buffer level, like BBA and BOLA algorithms. And the third class is the hybrid class, which use both measurements, the TCP and the buffer level in the adaptation decision. And now, why these ABR algorithms may counter some problems when applying in peer-to-peer network. When the player requests a segment and received it instantly because of the prefetching, its ABR will get confused by measuring a very short download time. On one hand, it will estimate an infinite bandwidth due just dividing the segment size by the segment download time, and on the other hand, the buffer will just grow by one more segment in a very short time, since normally the playout is continuous and the buffer consumes while downloading the segment. As a result, the ABR adapts to these high measurements by choosing a higher quality. The infinite bandwidth, especially for bandwidth-based ABR algorithms, leads the ABR to switch up the quality, which leads in turn to rebuffering when the current bandwidth is not sufficient to sustain this quality. And for the buffer-based algorithms, the increased buffer level leads the ABR to switch up the quality also. And again, if there is not enough bandwidth, the buffer just will consume to a lower level, resulting to switching down the quality. And this scenario, if repeats more often, it will lead to frequent quality switches. And to overcome this problem, since the instant delivery of the peer-to-peer cache segments lead to overestimating the bandwidth and the random buffer variation, and our main goal, or the main purpose of this work, is to keep the ABR unmodified and agnostic of the peer-to-peer network. We thought of influencing the ABR externally by adding a delay before returning the requested segment. So that's why we called our method the response delay, just because we are delaying the segment responses from the orchestrator to the player. And inspired from the two main classes of the ABR algorithms, we propose two approaches: a buffer-based approach called BuffDel and a network-based approach called NetDel. In short, the buffer delay, or the BuffDel, maps the segment delay to the buffer occupancy. It speeds up the delivery when the buffer level is low, and it slows it down when the buffer level is evolving to reach the maximum target, and thus we avoid the buffer underrun. The NetDel computes the segment delay as the time needed to be downloaded through the available bandwidth, and it mixes the contribution of the peer-to-peer and the CDN links to drive the ABR to select the higher quality that can be sustained via the highest link. To evaluate our methodologies, we run experiments on 4 ABR algorithms: BOLA, BBA from the buffer-based class, Panda and conventional from the throughput-based class, using 3G varying 3G traces and comparing 4 main scenarios: CDN only, where we don't have peer-to-peer; NoDel, which is the normal peer-to-peer without any response delay; BuffDel and NetDel represent the proposed approaches. To start with the quality of experience metrics. In these graphs, we plot 4 evaluation metrics to compare 4 scenarios, like the ones we talked about: CDN only, NoDel, BuffDel, NetDel, within each ABR algorithms. Starting with the average rate, and we see that using both response delay methodologies, we increase the average rate compared to the CDN only scenario. The NoDel scenario has the higher average rate, which is expected, as we already explained that the side effect of the fast delivery of the segment of the peer-to-peer segments. The consistency metric The consistency metric reports the rebuffering events. Here we see clearly the problem on the throughput-based algorithm, the conventional one, and we see that with the NoDel has the lowest consistency among all the other scenarios, and we managed with NetDel to improve the consistency of this metric to be as good as the CDN one. The stability reports the quality switches, and which was the main problem for buffer-based algorithms, as we see now with BOLA and BBA. And we see that with NetDel, we improved the stability of these two metrics. The last metric chosen here is the smoothness, which is the amplitude of between the quality switches. And we clearly see that conventional is improved the most one, since with nodal this algorithm oscillates between the lowest and the highest quality more often. Moving to peer-to-peer metrics, starting with the first and maybe the most important peer-to-peer metric, which is the peer-to-peer offload. This metric reports reports how much we save in terms of CDN usage. And we see that both approaches improve the peer-to-peer offload comparing with the nodal scenario. The second metrics we will talk about are the overhead metrics. We said that the prefetched peer-to-peer data is either useful when the video player requests it, or it's useless if the video player doesn't request it. Here we differentiate between two kinds of overhead. The peer overhead, which is the data that's not used for the peer itself, but it's shared between other peers in the peer pool. And we have the peer pool overhead, which is the overhead for the peer and the peer pool. And for each type of this overhead, we introduced a new metric, and we call these metrics peer efficiency and peer pool efficiency. And we see now with NetDel we improves both metrics compared to the nodal scenario, except for conventional, as we see here, since this algorithm is broken by the overestimating the bandwidth, and it requests the highest quality from the CDN most of the time, so less peer-to-peer data in the end, which means less overhead. That's why we have higher efficiency, peer pool efficiency and peer efficiency with conventional algorithm. Lastly, we compare both methods in real commercial experiments thanks to StreamRoot technology. These results show that BuffDel achieves a higher average rate and has more time spent on the maximum quality compared to NetDel, which reduce the quality switches and the rebuffering duration while improving the peer-to-peer offload comparing to BuffDel method. To summarize, in this paper we introduce response delay, a method to enable HTTP APR algorithms in peer-to-peer networks. We achieved some good quality of experience method, like we had good stability for the buffer-based algorithms in particular, and good consistency for throughput-based algorithms especially. We recommend NetDel as a cost-efficient, stable and smooth solution, and BuffDel for the good average quality. The learning-based algorithms are not covered in this work, likewise low latency constraints, which is part of our future work. So that's it. I hope you enjoyed it. Thanks very much for listening, and please share any question you have. Thank you.